In this video, I will show you how to fit simple regression using JMP. So this is a time series data about the cell phone subscribers. The response variable is subscriber connections in millions. The independent variable or the explanatory variable is the date. Now, after we fit the simple regression model, we also want to do a forecast. For example, we want to forecast the next time period, 2012. So I enter 2012 as the last observation under the explanatory variable date. So let's fit the regression now. So go to Analyze, Fit Model, select Subscriber in millions as Y, the response, select the date as the explanatory variable as X. So click on Add, then Run. Now you can see the intercept and the slope estimate down here. So usually you can also just save the confidence interval for both intercept and the slope. So click on the red arrow, select the regression reports, show all confidence interval. Then you will have these 95% confidence interval for the intercept and for the slope. You can also save various output from JMP. For example, under save columns, I can save predicted values, save residuals, save the prediction interval by selecting individual confidence limit formula. Everything we have just saved will be listed in the data table. Predicted values, the y hat, the residuals, the prediction interval, including the prediction interval for the new response for 2012. So we have the prediction for 2012. We also have the 95% prediction interval for 2012 in terms of subscriber connections in millions of dollars. Now, since we also save the residuals, you can actually plot residuals. For example, if I go to Analyze Graph Builder, I can move residual to Y, then plot against the date. I can get rid of this smoothing line, so only see the scatter plots, the data points, or you can do a line plot, connect all these points. So that's the residual plot. You can also, of course, plot residual over predicted values. Now let me go back to the regression output, regression data point. So what I'm going to do now is to analyze the residuals via Analyze Distribution. So select the residuals, click on OK. Now I have the histogram plot and the box plot for the residuals. You can, of course, turn this around. So go to histogram options vertical, turn it off so it's become horizontal. It's easier to read. The box plot and the histogram. You can also see the median various quantiles for the residuals. The median is 0.844. The mean of the residual should be 0. So 6.086 times 10 to the power of negative 12. So that's a very, very small number. It's 0, in fact. We can also obtain the normal quantile plot. Since the residuals are within the confidence bands, so it looks like roughly normally distributed. Let me go back to the regression outputs. Let's do the Durbin-Watson test. So click on this red arrow, go to row diagnostics, click on Durbin-Watson test. So JMP will give you the Durbin-Watson test statistic 0.2476A43. It looks significant because it's far below 2. And you can check using the table, compare with the table. Let me see. So the Durbin-Watson test. So number of observations is 29. Let's go to the slides. 29 around 30. So since the Durbin-Watson test statistic is below 1.49, you should reject it now, that the autocorrelation is 0. This is can also, so you can compare the Durbin-Watson statistic with this table. Another way is to output the p-value directly. Click on this arrow key, select the significance p-value. Since the p-value is from the corresponding Durbin-Watson test statistic, 0.2476843 is the p-value is less than 0.0001. So it's very small, less than the 5% significance level. So you reject each now. So it's the same conclusion as if you compare the Durbin-Watson statistic 0.2476843 with this value, the table, it's less than 1.49. I will also show you the log transformation. So in fact, I can do the log transformation for both state, natural log transformation. So it's a new column, and the subscriber connection. New column formula transform natural log. So these are the natural log transformation. You can also do the base 10 log transformation if you want, log 10. We may not use it. Base 10 log transformation. So you can fit regression model again using log based. For example, I'm gonna fit natural log of subscriber connection as Y, natural log of date as X. Click on run. And again, I can save all these various output, for example, predicted values, individual confidence limit, the formula. Now, for the new observation 2012, the predicted value of log using natural log is 6 point something. So I, in fact, can recover the number of subscriber connections by doing new formula column transform exponential. So if you did a regression using log 10 transformation, you can do a power 10. So right now, let me do an exponential. So I can recover the prediction.